Hello, good morning. Welcome to today's lesson on integration by part. Today we are looking at how to use integration by part. Okay, so now let me first quote the general form of integration by part now. So the formula is integral of u dv, which is equal to u v minus integral of v du. Okay, so this is the general formula. Okay, so now we have something called LIAT. LIATE. Okay, so this one means logarithm. This one means inverse trig. This one means algebra. And then this one means trig. And then this one means exponential. Okay, so now we use this one called LIAT to determine our u. So when we are preparing to determine your u, we use this we call LIAT. So we are going to scan through the question, the problem being given, to see if is there a logarithm. If there is logarithm, then logarithm should be equal to u, and then the rest should be equal to dv. If there is no logarithm, then we move on to inverse. If there is inverse, you do that. If there is no inverse trig in there, then you move on to algebra. If there is no algebra, you move on to trig. If there is no trig, you move on to exponential. So now see the way it is being done. Now I'm scanning through this question. I can see that there is no log here. So I'm done with L. So I'll move on to I. I've seen that there is no inverse trig here. So I'll move on to the next one, which is algebra. So I can see that there's an algebra here, which is x squared. So for that matter, my u will be equal to x squared. Okay, and then the rest will be equal to dv. So dv will be sine x dx. Okay, so now let me integrate this. Sorry, let me differentiate this. So I'm going to differentiate u with respect to x, which I'm going to get 2x. And then I'll make du the subject. So du being the subject will be equal to 2x dx. Okay. Now I want to find my v also here. So I'll integrate both sides. So I'm going to integrate this side and then integrate that side. So now the integral sign will cancel the d. Now to left with v at this side, which is equal to, if I integrate sine x, I'm going to get negative cos x. Okay. Now from here, let me write my formula here again. Okay. Now just by substitution. Now my u is equal to x squared. So integral of x squared, and then dv is sine x dx, indicating the original question, which is equal to, now my u is x squared, and then v is negative cos x, minus integral of v is negative cos x, and then du is 2x dx. Okay, so now I'm going to get negative x squared cos x plus integral of cos x 2x dx. Okay, now still there is an integral sign here, so we need to do the integration by part again. So we need to do it the second time. So the motive is to take off all the integral signs from there. After that, that will be your final answer. But as we can see, there's an integral sign here again. So we need to integrate this one again using the integration by parts. Okay. So the second So this one being the first iteration. So this one being the second iteration. Okay. So I'm going to integrate. So the second iteration will be based on this one because that is where the problem is. So integral of cos x 2x dx. So you are going to integrate this one again. So now let me factor the 2 out, and then it will leave it cos x cos x. So let me write it this way. So I'm going to get 2 out to level x cos x dx. Okay. So now I'm going to go by the layout again to determine my u from this question. So based on the layout, there's no logarithm here, there's no inverse trig here, but there's an algebra here which is x. So now my u will be equal to x, and then du dx will be equal to 1, and then du will be equal to dx. Okay, so the rest will be equal to dv. So the rest is cos x dx. So I'm going to take the integral of both sides. So d will cancel the integral, then this side will have a v. So now if you integrate cos x, you are going to get positive sine x. Okay, so now let me continue from this side. Okay, so now the formula is integral of u dv equal to u v minus integral of v du. Okay, so now my u here is x, so x here, and then my v is sine x minus integral of my v here is sine x, and then my du here is dx. Okay, so now x sine x minus this one will be, if I integrate sine x dx, I'm going to get negative cos x. Okay, and then since this is an indefinite integral, I should add the constant c. Okay, so this one will be equal to x sine x, negative will be positive, cos x plus c. And then now there was a 2 in there which I factored out, so I just integrate this one. So now my final answer here will be 2 multiplying x sine x plus cos x plus my constant c, because it's an indefinite integral. Okay, so therefore I'm going to get 2x sine x plus 2 cos x plus c. Okay, so now the whole of this is where we started the second iteration. So the integral of the whole of this is what we are having here. So I'm going to write the whole of this one, then I'll substitute this by this. Okay, so now integral of x squared sine x dx, which is the original question, is equal to negative x squared cos x plus this, then this is the integration. It will be equal to 2x sine x plus 2 cos x plus c. So therefore, the integral of the original question will be equal to negative x squared cos x plus 2x sine x plus 2 cos x plus c. Thank you. So this is how you integrate a function using the integration by parts. Bye.